So I've been looking for a new backend for my website, DZ Haven. It's currently written in Node and Express, and I wanted something that scales better. So after doing some research, I found that there is sort of this somewhat newer framework called Vert.x that is one of the top performers on Tech Empower. Just about in each one of these benchmarks, it's somewhere either inside of the top 10 or very near it. And actual performance wise, it's within probably 10 or 20% of the top, which most of the time is the Rust Actix service. So just to be clear, for me, 10 or 20% performance difference is really nothing, because if you're on a hot code path and you introduce something a little bit complicated into that code path, or maybe you add a new dependency, you could very easily lose that 20% difference. So for me, it was nothing. And just the fact that it was in the top 10 and it was using one of the C-based languages that I'm already familiar with was definitely a big incentive for me. The other thing is that internally it actually uses a JVM called GraalVM, and this JVM will allow you to use currently about half a dozen different languages, and even use them simultaneously in the same project. I believe currently they support Java, Kotlin, JavaScript, Ruby, Groovy, and eventually I think they intend to support Python. So if you take a look at these benchmarks, so you can see, for example, multiple queries, right? Pretty common task for a web server. This score is actually amazing. Roughly a 5% difference. By the way, ES4X is based on Vertex, but it uses JavaScript. So clearly one of the top performers. Now, if you look at what I'm using right now, Node kind of raw is 26% from the top. I believe the fastest Node framework currently is Fastify. And Fastify MySQL, which is the fastest combination of a Node service and a database, is 22% still. So very far from the top performers. And like I said, Vertex also supports using JavaScript as well, either through this, which allows you to use JavaScript, throughout the entire stack, or with Vertex proper, which allows you to mix and match different languages at the same time. So great performance, really good benchmark scores. It's already being used in some pretty big places. For me, having a finance background, the fact that an investment bank is using them definitely says a lot. Obviously, Groupon has enormous scaling needs. So does Red Hat. So does VMware. So does Hulu. So I think that it's a top performer, and being able to use multiple languages is just, icing on the cake. So we already saw some of the things that make Vertex extremely fast, but let's do an overview of what Vertex actually is. So Vertex is actually not a server framework specifically. It's actually a set of lower level components designed to help you create high performance applications. those applications are not of the variety like, say, something that does 3D rendering or something that does very repetitive, large data set mathematic calculations. Actually, those types of tasks scale better using threads. Vertex, on the other hand, is about scaling to accept more number of concurrent users, more simultaneous connections to databases, tasks that are primarily I/O bound, which in general are server tasks or REST APIs and things of that nature. At the core, the main engine that allows this to happen is the event loop. So this event loop is the same event loop concept inside of Node. You have an iteration loop with some arbitrary number of tasks, and it just iterates or loops through each one of them, and then goes to the next one and goes to the next one, etc. Inside of this event loop, although the event loop itself is not inherently asynchronous, all the tasks that run inside of it are supposed to be, meaning they're supposed to be asynchronous I/O tasks. There are ways to run blocking code in Vertex, and I'll get into that later. But the main driver for Vertex scalability is something called the reactive pattern, which is basically a pattern using callbacks, but the callbacks are supposed to be asynchronous in nature. All right, so let's get started with the project. The easiest way that you can create a new Vertex project is by going to start.vertex.io. And obviously this is a tool that helps you create a new Vertex application. 3.9 is the latest version. Just be aware that 4.0 is going to be releasing probably sometime this year, possibly within the next couple of months. They've been making pretty fast milestone updates. By default, you have to choose one of these two languages. However, like I said before, it's still possible to mix and match once you set up the initial project and have a foundational language. And I'll show that later. There are two build dependency management main methods that Vertex apps are written in. I only know Maven, so we're going to cover that, but Gradle is another one. From what I've seen, Gradle is the style is more code based, whereas Maven is using an XML file. So the group ID is sort of like a company namespace for your project. So even if you have multiple apps, they would still live inside of here. And then the artifact ID is this project grouping or name itself. And then in here, you have the ability to, by default, have certain base components in your project, so you don't have to manually add them. So I've gone ahead and actually let me just show you something. So initially, when I was kind of going over the conceptual foundations of what Vertex is and how it works and stuff like that, it kind of makes it seem like Vertex is sort of very low level and doesn't have much built-in capabilities. But actually, I just want to make it clear, there is a ton of built-in functionality for almost all of the common workflows that you're going to need to do. So here you have the HTTP component that allows you to do, typical HTTP stuff like setting up the service, setting up routing, doing sessions, CORS handling, CSRF, all that stuff. This is a web client allowing you to make HTTP requests. There's even support for GraphQL, which I'll be talking about in a later video. There's Web API contract help. There is a lot of support for different databases. So just to be clear, this and these will overlap, but the difference is this is a blocking library and these are reactive, meaning async IO, non-blocking. So you want to prefer these if at all possible, but if you need to use the older client, like I said, there's ways to run blocking code, and I'll get into that later. Redis support is also here. Cassandra, if you use that. Ability to create microservices. RX Java support is here. Messaging systems, AMQP, I think is a popular one. So it really does have a very large breadth of capabilities built on top of the Vertex core. So I just want to make that clear. Now, I've already gone ahead and downloaded a very bare bones project. So I'm going to show that right now. Okay. So when you create a project, by default, you're going to get the main vertical. Like I said before, you always need at least one vertical to have a Vertex application. But before I get into what you see here, I want to talk a little bit about what's inside of a project by default. So as I said before, this is a Maven project. Basically what that means is it's very similar in concept to a Node NPM project. So in Node, you're going to have a package.json file. It's going to list a bunch of dependencies in there, maybe allow you to run some scripts, stuff like that. So the analogous file inside of Maven project is going to be pom.xml. So inside of here, you're going to list out your dependencies, right? So you're going to have, just like in an NPM project, before you can have an import statement on some dependency, you have to have it in your package.json file, and you have to have downloaded it. So this is a very similar thing in a Maven project. Now, starting from the top of this file, again, we have our group ID, we have the artifact ID, which is sort of the container ID for the project. And then we have the version number right here. But the big thing you want to be aware of is this. This tag right here is basically telling the system what is the first vertical that needs to be kicked off in order to make the application start. So because this is here inside of the actual main vertical, you don't actually need to have a main method to bootstrap off of. Now for what we're going to do, which is to use the debugger, we're going to have to add main because VS Code doesn't kick off of Pommel. It kicks off of its own configuration, and I'll show how to do that later. But if you're not using the VS Code debugger, like if you're using a different IDE, then technically you don't need a main method. Now for this main vertical, as you can see, it indicates the package that it needs to be a part of. It indicates imports. The main thing is you have to create a vertical that inherits off of abstract vertical. So if you do that, there's multiple overridable methods that you can hook into, but the only one that you have to have is the start. So this guy is going to basically be the main bootstrapper. If you're using main, there's some other things that will have to go in there, and again I'll get into that later. But this is the main bootstrapper for the application that's going to initialize, for example, other verticals that you might be wanting to use, or in this case the HTTP server in this simple example. Now the reason why you're seeing these warnings is that so Vertx right now is in version 3.9, so it's actually pretty mature. So they've gone through several iterations. They've deprecated some older functionality, and they're continuing to evolve the system. So this these deprecation warnings, they're currently just warnings, but probably in version 4.0 these functions will be removed. So just be aware of that. I think the reason why they're still here is because this project has not been fully updated for 3.9 yet, but it actually doesn't matter because this still will run successfully. So I just want to check that I'm in the right place right now. Yep. So let's just change this a little bit. So in the README, they give you a script that will help you start up the service. All right, so starting from the top, you want to create an HTTP server. This is going to be the request handler. Inside of here, you have the response, the header to the response, and then when it finishes, obviously it's saying write hello world. This is really more about logging this callback right here. You know, if it's successful, I'm going to log whatever I need to log. If it failed, maybe I need to do some other work here, notify something, etc. So if we look at the result, we have hello world. So this is not, you know, obviously a realistic example, but I wanted to show at a base level, as I said, what you need to just simply get started. Okay, so now let's enable the debugger. So the first thing you want to do is change this to basically what you saw in the pom.xml file. So this is going to tell the system that this class is the one that needs to be executed first. So then on top of that, you want to, like I said before, because in the end, this is really, just another Java project. So you want to have main, or you need to have main, because Visual Studio isn't aware of your POML file. So what that means is that you need to execute this. So let's put a breakpoint there. So again, because Visual Studio doesn't know about Maven and POML files, you just have to run this as far as Visual Studio is concerned, just like a regular Java app. And therefore you need main. In this case, we're going to do an instantiation of this vertical class explicitly, and that will run this code. If you, where am I? Okay, so let's put a breakpoint there. Those messages are just Mac specific messages. I'm using Catalina, by the way. Okay, so we hit that breakpoint. We hit the breakpoint here. Just be aware, as I was explaining earlier when I was talking about Vertex conceptually, the event loop itself is not asynchronous. The tasks that are running inside of it are supposed to be. So it's very sensitive to delays. It's very sensitive to blocking. And if anything goes beyond a certain amount of time, as you can see here, it's going to consider that an issue and throw an exception. So in our case, obviously, we were hitting a debugger breakpoint, but the system doesn't know what the root cause is. So you always want to make sure that you're not either completely blocking the event loop with a non-asynchronous call, or even perhaps you're thinking you're doing a fast async call, but for whatever reason it's slow because the database is slow or some other service is slow. If it gets beyond a certain amount of time, it's going to consider that blocking code and it's going to throw an exception. If it gets past that, you will be able to continue as we saw, but you just want to be aware of that and cautious. Okay, so let's flesh out our application a little bit more and add another vertical. So in order to, so what I'm going to do is I'm going to add a vertical for doing web related stuff. And in order to handle that, for example, doing routing, I'm going to have to add another dependency. So as I mentioned before, the dependencies are handled in the pom.xml file, and this file is analogous to the package.json file in npm. So if we go here, I'm going to add the dependency for the web. So that's going to be this. You want to say true or always for this, because the class path needs to be updated for Java to work properly. But this is the dependency that's going to give us things like routing, if we want to use it, session state, cores, stuff like that. So if we go back, let's create a separate file. So we'll call it HTTP vertical, right? In the same way that main is part of this package, I'm going to add that. And I want to add, actually, let's just add all three. The abstract vertical. Whoops, spelled that wrong. Okay, so in this case, just to get up and running, let's just leave the start empty. For now. Let's get rid of this. So what we're going to do just to get started is we're going to launch a secondary vertical from the main vertical, which is generally how things happen inside of Vertex. You have a main vertical, and then any other verticals, any other distinct verticals that you might need would be kicked off by the main vertical. And then it's also possible that those secondary verticals might kick off their own, verticals of their own. So inside of start, we're going to initialize the HTTP vertical that we just created. All right, for now, let's just make sure that this will work. So let's see. All right, so hello HTTP vertical. All right, so I know this doesn't do really anything right now, but I just going through this process tells you about, the core or the base things that are needed to get things up and running. And you always need that single base vertical to bootstrap everything else off of. So after we do that, we're going to fill out, or we're going to populate more our HTTP vertical. And so like what I was saying before is this thing will do routing, it will do logging, it will do cores handling, and various other features. But for our demonstration app, let's just keep things simple. So let's add the router. So I need to import. Just make sure when you're importing in this way that you're importing from io.vertx. Vertex internally has a lot of capabilities that it grabbed off of Netty. So when Visual Studio is making suggestions for what to import, a lot of times they're going to come from assembly paths that aren't related to Vertex, or at least what you're trying to do with Vertex. So just be aware of that, and make sure you're looking when you're selecting the imports. Okay, so we're gonna do, let's not add any features like cores or anything like that for now. Let's just keep things simple. So we'll just add a path. Let's do it as an API. We'll call it home. And then it's going to need a handler for that route. I want to put this in a function just to keep things clean. So what am I doing here with the event bus? So what I'm trying to do is I'm trying to componentize the application, even though it's a simple one, by having a separation of concerns so that the main vertical, or the bootstrap or vertical for everything else, is its own separate logical structure. And then that will kick off other things that it needs. And then this other thing that it needs, the HTTP vertical, is also going to keep some of the work related to it separate. So in this case, that means that although the router and the HTTP server are going to be set up inside of this HTTP vertical, the actual handling of a certain specific route is going to be done by a different vertical. So it's just a mechanism to do separation of concerns. Obviously, you don't have to do your application in exactly this manner, but showing you this process may trigger some ideas about how you want to structure your app and what's possible using Vertex. So in this case, if I want to handle something with the use of a separate, distinct vertical, then it's going to require that I send messages with the event bus so that communication can happen between two distinct verticals. So in order to do that, when I send the message, I need some sort of unique address. So that other vertical is going to have some unique identifier in order to be able to receive this message. So since our route path is home, let's just do something like this. We don't have any parameters, so I'm going to skip that. I'm used to JavaScript and C# syntax for lambdas. So when I get something back, I need to represent it. So I'm gonna do that. The context is roughly similar to the event loop context. So in this case, you have access to request and response. Obviously, this is part of the HTTP service. And then in the end, you're saying, hey, whatever I get back from this address, I want you to represent the entire body of it. Again, all the messages are passed as JSON. So take this, I make it the handler. Oh, sorry. In Java, if you want to pass basically a function reference instead of executing a function, you want to pass a reference to it as a parameter, you have to have this. So the object or the namespace that it's in plus this. So that's what that error was about. So then we're passing messages. There is some completely distinct decoupled handler somewhere out there. Obviously, loose coupling is a good practice. So we've done that. Now we need to create and then instantiate whatever it is that's going to be receiving this message. So again, in our case, that's going to be a distinct vertical. I'm going to call it home. Keep forgetting the name of these things. So inside of our, let's just copy and paste this. So inside of our start method, we're going to want to have the responder. We're going to want to know, what message or what response to give. And like I was saying before, I just want you to note, you can see how the options for what you want to import are kind of varied. So a lot of times Netty will show up first, so you want to be careful which one you select. So then now that I've done that, I want to actually respond to whatever message that I get. So I'm going to use the event bus again. And this time I'm going to consume any messages that go to a certain address. So we had decided that our address was going to be this. In reality, whatever is in here could literally be any string. So it could be a bunch of numbers. It could be, it could have dashes in it. From what I've seen from the docs, the standard is to use period. So home.period. home.addr.xyz, whatever you want to put in there. So then whatever message was being sent to me, I might use it as part of my response. But in this case, this is all I want to do. So now we have our home vertical. And we want to be able to initialize or create or instantiate that vertical. So so this is going to be a parameter that I'm not using. That's why I'm using underscore. And then I'll I'll show you very soon why that is. But in here, we're going to create the vertical just like we did before. So let's just do a quick rundown again. So we have the router. We have only one route. There's going to be a handler to it. It's going to be this guy. All home handler's job is to send a message using a specific address. At the end of doing that, there will be some response. It's going to output that into the response of the HTTP server. This is for the purposes of initializing our home vertical, which is going to be the handler that's going to address any messages or any requests coming to this address. So now what we have to do is initialize our actual HTTP server. Okay, so now that we've done the initializer for our other vertical, we're going to initialize our web service. What's going on here? I don't usually see this error, but anyway. So we need to create the HTTP server. Need a request handler. We need to pass the router to the request handler. We need to return a future. So if you're not familiar with Java, I myself actually come from what are we going to do here? 1, 2, let's just do that. I mean, I myself come from C#. Let me just type this out. Let's see what's happening here. Whoops. Okay. I myself come from C#, so Java is something that I'm still learning, but basically a future and promises are sort of roughly analogous to the task class in C#. So basically they or in Java promises. So they enable you to do asynchronous work where the result is coming at some future time. So the reason why it's important to know that is because if we are running this we can compose these calls, but in order to compose them, you need to be able to return a specific signature, expected signature, which is these, because the verticals, or even really anything that you do inside of a Vert.x function, may be asynchronous. So in this case, initializing this is not asynchronous, but being able to compose, that is, call a function, have it finish, call the next function, etc. It's expecting asynchronous tasks in order to maintain its non-blocking nature. So you have to return a future, even if in this case it's really not doing much of anything. So this is going to be the setup. So once again, this might be a little bit redundant, but if you're brand new to Vertex, I think this whole setup can be kind of confusing. So I'm just going to summarize and review it one more time. So you need the main vertical instance. Normally we don't need this, but just to get Visual Studio Code's debugger running, we have to have main, and I'm doing the initialization here. Once we do the initialization, we kick off a new vertical, in this case the HTTP vertical. Every vertical has to inherit from abstract vertical and override at least this one function. So then inside of HTTP vertical, the reason why it's distinct is it's trying to do only one thing. So that is the task of setting up the HTTP service and routing. So then once we set that up, we have to put in a handler for the one route that we have. In our case, the handler is sending an event bus message to this address. And because our work is separated even at the handler, the URL handler level, we have created another vertical to handle that URL and messages to this address. So again, it inherits from abstract vertical, therefore it overrides start, and inside of start it's subscribing to its own address and giving back some specific message. So that's the setup for the handler. And then to continue, the setup for the HTTP server is here. In our case, we're just doing pretty much a vanilla setup. We're passing the router that we constructed over here as a parameter. So then it knows what the routes are, what the handlers are. We've set up to quadruple 8 as the port. After we set up the HTTP server, we set up the verticals. In this case, we only have one, which is the home vertical. So that's what's happening here. So let's just run this. Okay, so the reason why that happened is because we never set up a root route. So I was expecting that, but just to be clear, that's why this is happening. So in our case, the only route that we have is home. So as you can see, in our case, the response to the message coming to home.addr is welcome home, which is the message that you see here. I think the error that was happening before was because this service was still running when I had added the dependency to web here, and it didn't have a chance to reset itself. So that's it. That is a quick overview of Vertex and verticals. In the next video, I'm actually going to do a series that involves my migration on DZ Haven, taking it from Node and Express and GraphQL and converting the entire backend to Vertex. So it'll be a series. I'm expecting somewhere around 5 videos. Thanks.